Let's think about the equation that we've seen for forces, and it looks like this. The magnitude of the force between two charged objects is k times the magnitude of charge 1 times the magnitude of charge 2 divided by the square of the distance between them. So in each of these cases, a small positive charge is placed at the black dot in this picture. Question, in which case is the force on the small positive charge the largest? And then in which case is the force on the small positive charge the smallest? Talk to your neighbors about this. I'm going to call for a vote. Where is the force big? Where is the force small? Which case? Let's do a vote. In which case is the force on that small positive charge the biggest? Case C. How come that's the biggest? Small distance and big charge. Charge 2q, distance r. Big charge, small distance equals big force because the force is proportional to the charge and it's inversely proportional to the distance. Which case is the smallest? D. How come it's D? Large distance, small charge, small charge. Okay? So this one's the biggest, that one's the smallest. And those are the trends that we see. Let's look at multiple charges. Imagine putting a small positive charge at the black dot in each one of these scenarios. So scenario 1, A, B, C, and D. Small positive charge goes here. Question. In which cases is the net force on the charge to the right? In which case is it to the left? And in which case is it 0? And so you're going to think about multiple charges happening here. Talk to your neighbors about it. And I'll call for a vote for right, for left, and 0. Okay, which one is to the right? Which one or ones is to the right? B. Because think about it. This is a small positive charge. There's a force from this charge on it. Which way does it point? To the right. There's a force from the negative charge which points to the left. How come this force is bigger than that force? Closer. It's closer. And so the repulsive force which goes to the right dominates. This one, repulsive to the left, net force to the left. This one, I have an attractive force to the left, I have a repulsive force to the right. Which one's bigger, the attractive or the repulsive force? The attractive force. And so that one, the net force will be in what direction? To the left, to the left. So left, right, left. How about this one? 0, because it's going to have an attractive force to the left and an attractive force to the right, but they'll have the same magnitude. Now, let's add forces. All these charges have the same magnitude. We're asking this question. I place a small positive charge and put it at the dot, and the question, in which case is the force on the small positive charge the largest? In which case is it the smallest? Okay? So think about adding the forces for the different cases. Go ahead and talk to your neighbors. I'll call for a vote in 30 seconds. Okay, let's go ahead and vote. Which of these cases is the largest? It's case A. How come case A is the largest? Well, let's look at it. right here, a small positive charge, what force does it, what direction is the force it feels from this positive charge? To the right. And how about the force from the negative charge? To the right, okay? Why is that bigger than this one? If I have a positive charge here, it's going to feel a force from this one, which is to the left. And it's going to feel a force from this one to the left, but it's smaller. It's smaller. So the two forces are in the same direction, but one is small, one is big. In this case, they're in the same direction. They're both big. How about this one? I'm going to feel the force from the negative charge is to the left. The force from the positive charge is to the right. They're opposite directions. That's not a candidate. Which one's the smallest? D. Because I have a force towards the negative charge on that side, towards the negative charge on that side, net force 0, hard to get, much smaller than that. And so the largest is this one, and the smallest is that one.